Okay, that's fine. Okay, so okay. So that's pretty good. So what I need to do now is, so what I will do now is to copy this file, copy it here, copy. Then I'll go to my AMOS file. I'm going to share my AMOS file. Then I'll go to the pattern matrix builder. Select the data. Then come here, these points. Tutorial. Then I will first. So you can see, I've already built, I've created my factors. So you can see those items that we have in that, the outputs of the pattern matrix, that factor analysis. So you can see that they are here now, okay? So this is how you will start the analysis, because I worked on 4 factors, okay? 3 factors, sorry. I worked on work placement learning, learning certificacy, and leadership skill. So I will come here and I will name this one, let's name it placement. Here, efficacy. Here, I will name this leadership. Okay, so at this point, I need to save, and I will save. I can simply save it on my desktop. Okay, something like this. All right, so in this particular case, what we need to do now is that I'm now doing the confirmatory factor analysis. Remember that AMOS is very, very sensitive to a lot of work. So in most cases, when you run the analysis and run into problems, it does not mean that what you are just like I did and it didn't run well. You just have to close AMOS and then reopen it. That has always been the way it works, okay? Then I will come to analysis property. At this point, what I need to do now, because all is fixed, you can see all those items, item 1, 2, 3, 4, blah, blah, blah. Look at them here. And they are on their individual factors, okay? The scales, the variables, okay? So, and these are the correlations, because you need to put the correlations, right? So what I need to do now is that I will come to analysis property. I'll go to the output. I'll select the standardized, and then I'll select the modification indices, okay? And then I will close. Now, I will save, and then I will try to run AMOS. Let's hope it runs. Woohoo! Okay, so what we'll do is we'll close AMOS. Okay, so this is the AMOS, and yeah, I hope we can see. We can see the screen now, right? And so the AMOS runs.
Yes.
This is the this is where you click. When you click here, when you click, this is calculate estimate. Calculate estimate. Okay. So when you click on calculate estimate, it runs, and this view the output bar will shine. This particular case, it will shine, it will be alive. You can see it's alive now, meaning that you can actually shake the value. So you can see these are the output. You have the unstandardized and you have the standardized output, right? So you want to look at now that threshold that we are looking at, that we read before in a paper, that the individual items are actually supposed to load above 0.7. So you can see from the pattern matrix that we did, you could see that it was only 2 items that were loading well. So we may likely have challenge of meeting model fit in this particular study because the items are not doing pretty well. Like you can see here, this is 0.49, which is so bad. But if we remove this item, AMOS will not run because with the new version of AMOS from version 24, you can't have below 3 variables. This is the lowest you can have to measure a scale. Okay, so already we are not meeting a very standard. We are not meeting a good data fit here. Okay, so let us go to view test and see what AMOS will show us on the view test. So this is the AMOS output. So you can see here, we will simply go to the model fit. That model fit that you're hearing, we simply go to the model fit, and then we'll begin to check whether we are meeting the threshold. Now, look at here. This is the chi-square divided by the chi-square divided by the degree of freedom. This is the chi-square. The CMNI is the CMIN is the chi-square value, and the degree of freedom is 62. Okay, and then when you multiply this, when you divide this value of chi-square by this 62, you get this. And according to the previous scale that I have shared, okay, let me show you now. Now you can see here, look at the metrics that the CFI, which is confirmatory fit in comparative fit index to colloquial indices, must be above, at least from 0.9 and above, and that the chi-square divided by the degree of freedom have to be 0.3, less than 0.3, like from 0.3 downwards. Anything above 0.3 upwards is bad. So this is the threshold. So these are the things we need to watch out from our study and then report them in our study. Okay, this one is 3.0, but look at our CFI, look at our Tukolewis TLI, and look at, so you can see that we have not achieved the metrics. Now look at the RMCA, SES. So what we need to do is that we have to go back to the model. We can go to modification indices to check, or we go back to the items and then know what is the problem and then start removing some items. When we remove the more items we remove, we may likely achieve the model fit. So what you do here is that you can see that item 12 is also not good. But as long as we have this item, I like to tell you that as long as we have this item, we are not likely going to meet the model fit. We are not likely going to achieve a wonderful model fit because the instruments that we have, the data that we have collected ab initio, have not loaded properly, have not done well, okay? Have not really done well, okay? In the sense that we have issues with reliability of the overall instrument as we struggled in SPSS. So here, you can see that because of this value, in fact, in this total scale, in this particular one here, none is even above 0.7. None is up to 0.7. So because of it, we will consistently have problems with this model, okay? So what we might do is that we can go on to remove this particular item. Remember, when you remove a particular item, make sure that in your paper that you report why you removed it, because you can see this one, it's not loading well. So when you remove, you calculate again, and then you check. See, this is still 0.59, looking bad. And then let us see. Go to view test. Okay, so you can see that even while removing that item, that we have still not been able to achieve this metrics. Look at it. Here must have to be 0.9 and above. CFI, comparative fit index, it has to be above 0.9. So you can see here, this have to be above 0.9, this have to be above 0.9, and then the same thing here. So this data is not fitting the model. There is no justification for moving on to test your hypothesis and then claim that you have established cause and effect with this model, with this particular model fit summary that we have. Okay, so even if you covariate error terms, and then look at, and again, one thing I want to let you know is that, see here, that the degree of freedom dropped from 62 to 51. So as you remove items, the degree of freedom will keep on reducing. So you need to be very careful to be specific with what we are doing. So another thing we might want to do to know whether we can achieve model fit is to go to modification indices. And then when we go to modification indices, we try to see covariance. We can look at to know whether there are like item 1 and 2. Are you looking at what I'm doing? You can see item 1 and 2 is 26, is 26 point something. Are you looking at that?
Yes, we are looking at it.
Okay.
Yes,
Okay.
yes.
So what you do, so here now, what I want to do is that I want to covariate in that output under covariance. It's suggested that we can covariate error term 1 and 2. But there's something I need to tell you about error terms. We have to check, is the error term 1 and 2 in the same factor? You can see that error term 1 and 2, if it is, this is error 1, this is error 2. So they are in the same factor, so we can covariate it. If this error term, unobserved variables, if this is error 1 and we have error term 2 here, we cannot covariate from here to here. We cannot. A lot of people will go and covariate from here to here to forcefully achieve the model fit, so we don't need to do that. Okay, so what we need to do now is that we select all, and we'll give a little space here. Then we covariate error term 1 and 2. So when we covariate error term 1 and 2, and then we rerun the analysis to see if there is any improvement, if the model is going to improve. So we go to the output. Are you seeing the output? So you can see that we have the CFI has risen to 0.90. Are we seeing the CFI value now? Are we together?
Yes, sir.
So can you see that? Can you see that the CFI has risen to 0.981?
Yes.
So this is good. So you can see that incremental fit index has risen to 0.909, which is 0.91, 0.91. But our TLI is still bad. And then if we look at this chi-square divided by degree of freedom, you can see that it has further reduced to 3.07. Okay, it has further reduced. So now let us go back and look at our RS. You see our RMSER, the Riemann square error of approximation, has reduced further. Okay, and then let us see what happens if we go back to modification indices and see if there are other the biggest. Those, look for the biggest ones, the largest ones, and then see whether we can covariate them to further achieve the model fit. Okay, let us see. The highest number here is 13, which is 5. I think
14, sir. We have to.
No, 14. We cannot covariate from factor. This, this is a factor. Look at it here.
Yeah. Okay.
So this is a factor. We can't covariate from factor to items. No, we can't do that.
Yeah.
We can't do that. Okay. So, but what we might do is that we need to look at. So the next biggest one now is 13, which is 4 and 10. So what we need to do is simply go to the pattern matrix, and then we check 13 and 13 and 4, 13 and 4. Okay, so we'll go back to 13 and 4, 13. So they are not together, right? Are you seeing that 4 is under placement and then 13 is under leadership? Are you seeing that?
Yeah.
So this is the much you can do. On a second thought, you may also want to see whether if we further remove. Okay, so we can't remove here. So the only problem that we have is this particular case. That is why we cannot achieve. So if you want to report in your study. So you can only report that under model fit that you were able to achieve chi-square divided by degree of freedom. Yeah, you were able to achieve this. So now let us calculate. Let us calculate using. Yeah. Are you seeing what I'm doing?
Yes, sir.
Under pattern matrix, you can see model fit. So I have a lot of plugins here. Which I use. So what I need to do now is that I will calculate model fit measures. So I will click and I will say, it will ask me, does your data have missing file? I will say no. See why it's very important to ensure that you don't have missing data. So it's going to run, and then when it runs, it's going to produce. So it's going to produce the results, and then you will see what the AMOS will tell me about my model fit. Just 1 minute, please. It will take a little while to open. Okay, so you can see that at this point, so colleagues, you can see that this is the model fit measures that you see us report in the papers. So this is the model fit measure. So this is the chi-square divided, this is the chi-square value, 153.66, degree of freedom, 50 point this, chi-square divided by degree of freedom. You see, interpretation, threshold. Chi-square divided by degree of freedom, you can see the threshold here. Between 1 and 3, interpretation is acceptable. So this can be acceptable in your paper. The CFR, it has to be at least 0.9 and above. But I have 0.908, which is 0.91. This is acceptable. The SRMR is supposed to be below 0.08. This is excellent. But you can see my RMS root mean square error of approximation is terrible. This can't work. So reviewers will be waiting for your paper to report RMSEA that is not good, that is terrible, and they will ask you why. Okay? And so we have also P-close not estimated at all. This one is because it must have to be above 0.005. So this data has an issue. Okay, it's good that I'm using a data that has a problem so that you can understand these errors. Because if I had used a data that is fantastic, everything is wonderful, you won't be able to understand when you run into problems. You will not be able to know that such thing can happen. That's why I'm trying to use this data for us to see that we can run into, when we run into problems, what we might likely do to improve the data. And if we have done that and the data is still not looking pretty good, we may need to go back to the field, right? So we don't need to force the research, the study to agree by force.